Dear participants, welcome to 5th International Congress on Human-Computer Interaction Optimization and Robotic Applications. The symposium is organized by Dukat Gazi Osman Pasha University from Turkey and National Technical University Kharkiv Polytechnic Institute from Ukraine. The symposium is technically sponsored by IEEE Turkey section. Thank you for your scientific computation and support symposium. Now let's start the first session of the day. If you want, first paper belong to dear Zurab Sabaktarishvili. Are you ready to present?
Yes, thank you.
Okay, if you are ready, you can start your presentation.
Okay, is my screen visible to everyone in the audience?
You have 10 minutes, please.
Yes. I'm Zurab Sabaktarishvili, a student from Arkansas Tech University from the United States. And our research project was centered about crime prediction using machine learning. And for our specific example, we chose a local city, the capital of Little Rock, the city of Little Rock. So to understand the crime, Little Rock is one of the most criminal cities in the United States. It consistently ranks among the top 15 most criminal cities. And one of the classic approach to tackling crime and identifying crime zones has proven to be inefficient and costly in many cases. So our research was centered about using novel solutions to kind of analyze the crime and create predictive policing solutions. Another important note is that during our exploratory data analysis, we created this heat map displayed over here, which kind of helped us to analyze the crime behavior and the crime characteristics in the city of Little Rock. When we were first analyzing previous research and we were doing literature review, we determined that the most efficient way of employing machine learning for crime prediction solutions was to use deep neural networks, which was deployed in case of Chicago in another study, and it achieved accuracy of over 85%. So our approach was to collect data from the Little Rock Police Department, which was publicly available data, pre-process it using standard techniques, and then feed it to Facebook's profit model, which is a time series forecasting model, and a neural profit model, which is also another time series forecasting model developed by the Stanford University. And at the end of after our model evaluation, we decided to go further and apart from creating a citywide prediction, also try to create a zip code level prediction. So we evaluated on our model evaluation stage, we evaluated our machine learning models with industry standards metrics such as RMSE or MSE and mean average error. And we compared the error rates of these two models. And we hope that our results and insights would help lawmakers or law enforcement agencies in the Little Rock and Arkansas area to better understand and tackle the issue of crime. So on our initial stage of data collection, we used a publicly available data source, datalittlerock.gov, which provided API endpoint as well as a CSV file for that was almost real-time updated. And we went for a CSV file because that was ideal for our machine learning scenario. So after that, we employed standard process of data cleaning. We cleaned out 6% of the duplicates. We cleaned out misrepresented values or error values, which would not be fit for machine learning purposes. And after that, we already started further analyzing the data set. And our first stage was at appending additional columns to the existing crime information to better understand the crime characteristics. And the first step was to append whether each incident in the city was high risk or low risk. And we did that according to the FBI's Uniform Crime Reporting Guidelines, which helped us understand which crimes were violent and which were low risk, which would eventually potentially be helpful for our machine learning algorithm. So another important note for our EDA, exploratory data analysis, we determined that as we were reaching COVID, the crimes were going down, and then we see an uptick after the COVID was over in 2021 and 2022. So when we deployed our final model, our optimized model, and also the model which was fed with additional regressors in our data set, such as weather, we determined that in the long run, Facebook's profit performed better than neural profit, which is not expected. This may have happened due to these additional regressors that we mentioned, but also due to the vast amount of the data and also the unique characteristics of the crime data. We achieved a root mean squared error of 7.56 for Facebook profit. And to take that into account, the mean of the daily crime counts in the city of Little Rock was around 39. So these two are visualizations of the performance of these two models from 2021 to 2023, and we can see that both of these models perform fairly well against the real data. The green line over here is the forecast, which was done on the test set of the initial data set, and we can see that it's pretty much well aligned with the actual observed values. Our next level after the citywide prediction was zip code level analysis and potential prediction of crimes. And we determined the most criminal zip codes in Little Rock. We determined what were the most violent crimes in the Little Rock, and the same for its zip code level. But when we actually employed our machine learning model to zip codes to count daily incident counts in the city for each zip code, we didn't achieve promising results. This was mainly due to probably a lack of data, because for some zip codes there were 0 crimes per day, and the next day maybe there was 5 crimes. And for machine learning purposes, this was a hard data set to work with, so we did not include the zip code level analysis in our final paper. But that's something to keep in mind for future work. And well, our machine learning model is definitely not the perfect solution to the crime rate, but to the crime problem of the Little Rock, but it provides an insight into what kind of innovative solutions we can bring to the table when we are talking about crimes, and how we can use data analysis and machine learning to kind of aid lawmakers and also local business owners to make better decisions. And we hope that in the future, our model will get even better. And while it's impossible to predict human behavior, we can get better and better at it by providing additional regressors, such as census data maybe in the future, and other additional regressors that will help our machine learning model. The research was funded by the Arkansas Tech University Research Grant, and our research team was mentored by Dr. Robin Gosh, who was extremely helpful, and who mentored us to create basically on all stages of this project, and the Department of Engineering and Computing Sciences of Arkansas Tech University. And we would also like to thank Dr. Teresa Collin of Arkansas Tech University for providing valuable insights into the ethical considerations of such research, because this was a sensitive data that we were initially working with. And any questions? We got GitHub repository QR code, and also the crime heat map QR code over here if it will be needed. Thank you.
Thanks for your presentation. Dear participant, do you have any question about this paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Dear Zulab. Dear Aldeniz Rashidov,
Okay.
are you ready to present? You have 10 minutes, please.
Okay, thank you. It's okay. I will present you, dear colleagues, first, dear colleagues, dear ladies and gentlemen. I will present you paper with topic determining the level of preference for innovative services in educational institutions. The authors of this paper is Aldeniz Rashidov and Fatmir Rashidova from Technical University of Gabrovo, Bulgaria. Now, the first is thesis. The main tasks to be solved in the educational institutions are improving the way training is offered, choosing innovative services, teaching methods and approaches to meet the needs and preferences of learners, selections of appropriate innovative services to be used to enhance the learning process, advantages by determining the level of preferences of the innovative services. It can help to understand how innovative services can be effectively integrated into the learning process to improve it. It can improve the ways in which educational institutions offer training and can confirm that the methods used by educational institutions are effective and meet the needs and preferences of learners. How can the level of preference for innovative services in educational institutions be determined? Through various forms of outreach, such as surveys, questionnaires, and observations, information can be gathered about opinions and preferences towards innovative services. Once the information has been collected, it can be analyzed to determine the level of preference for different services. The analysis may involve calculating the percentage of participants who prefer a particular service, as well as evaluating the responses that determine the factors of influence preference. Purpose. The purpose of this report is to propose a method for determining the level of preference for innovative services to enable educational institutions to improve the ways in which they deliver training and to ensure that their methods are effective and meet the needs and preference of learners. Determining the LP shortly of services involves determining the relative weight importance of each individual services used in the instruction of students relative to the others. Popular in the field of multi-objective optimization for making optimal decisions is the so-called Stoyanov's method, which allows to determine weighting coefficients by ranking different target parameters. Stoyanov's method is based on the ideas of rank correlation and can also be applied to determination of the level of preference of services by ranking services instead of ranking target parameter. However, a disadvantage of using this method is that it does not allow to predict the values of the weighting coefficients in the later time period. Resolving this deficiency through modification will allow for a more accurate and stable solution. This is algorithm of the proposed method. The first is research the problem, next selection of innovative services, periodic data collection, creating rank matrices for different time periods, next calculation of coefficients of concordance, verifying the significance of concordant coefficients, calculation of weighting coefficients and determination of services preference for each periods, analyzing the preference of the innovative services, and the last is making the decision. The greater the number of learners and the frequency of data collection, the more accurate the actual and estimated weightings will be. As the algorithm is periodically applied, the accuracy of the predicted weighting coefficients increases. In order to process and analyze the ranking of the innovative services by the learners, it is necessary to store it in database. The ranking of the innovative services by the learners is stored in database, which includes the main structures: ranking, weighting, and preference. Structure ranking contains data with the ranked innovative services over different periods. Each value in the structure determines the weight that the learner assigns to the corresponding innovative service. Structure weighting coefficients contains data on the weighting coefficients of each innovative service during different periods. Structure preferences contains data on the LP of each innovative service during different periods. Data for feature LP, level of preference, is also stored here. Calculation of weighting coefficients. This is sequence calculating the sums of the ranks of each service in each period, calculating the average of all ranks for period N, calculating the deviation of the sum of the ranks for each service from the average sum S, calculating the agreement coefficients. Next, checking the significance of the agreement coefficient, and last, calculating the weighting coefficients for each service in each period N. Next is determining the level of preference. The level of preference is determined on the basis of the calculated weighting coefficients. The innovative service receiving the highest weighting receives the highest level of preference, and lowest weighting receives the lowest level of preference. Prediction of the level of preference for the next period. It is based on the least squares method, which is applicable to approximate with the arbitrary function that is linear with respect to the unknown parameters. This allows the search for coefficients of models that depend on two or more independent variables. The use of the high-degree polynomial method significantly reduces the difference between the actual and approximate values. The MATLAB programming environment allows a fast and simplified solution of the system for determining the unknown coefficients of high-degree polynomial. The analysis draws a conclusion about the periodic variation of the level of preference to given innovative service. Depending on different conditions, the following are distinguished: sustained preference, increasing trend in preference, permanent increase in preference, tendency to reduce preference, permanent preference reduction, and hesitant preference. Application of the method. Establishment of target indicators. This includes establishment of target indicators and student survey by discipline. Annually, during the course Programming for Mobile Devices in Department of Automation, Information and Control System at the Technical University of Gabrovo, Bulgaria, data are collected from the students on their ranked desired innovative service at the learning process. The first step is determination of target indicators and surveying of students. This is survey card. It includes 7 target indicators: interactive whiteboard, mobile application, educational applications, webinars, educational games, synchronous methods for communication, and asynchronous methods for communication. Second, calculation of weighting coefficients, level of preference, and feature level of preference. Observing the steps of algorithm, the collected data is transformed into relational scheme rank matrix. Table here shows the obtained data in the structure preferences for 5 periods corresponding to the academic years 2080 and 2022. in calculating the estimated preferences for the sixth last period, 2023, a polynomial of the fifth degree and results for preferences of the service from the previous 5 periods were used. The period collection of the opinions on the preferences of service favors the full application of the method, as there is sufficient number of periods with which to perform a more accurate prediction and analysis of the LP of each innovative service. Next step is calculation of weighting coefficients, level of preference, and feature LP. The first period, this is for second period ranking weighting coefficient for innovative services. First, second, third period, and fourth, fifth period. It is you see the interactive whiteboard is the first. Next steps is calculation of weighting coefficient for 2022 period according to the ranked weighting coefficients for this period. The top 3 services receiving the highest level of preference. This is interactive whiteboard, educational application, and mobile application. The lowest LP for 2022 is asynchronous communication. Last step is analyzing the level of preference for innovative services. Graph of the change in preference of the service for the last 5 periods is created and used to analyze the level of preference. Figure shows that the LP toward some of the innovative services is high compared to the others where it is relatively low. After analyzing the LP of each innovative services according to the conditions defined in the algorithm, the following results is obtained. Conclusion, the method under consideration provides an opportunity to determine the level of preference of the innovative services in educational institution. The method analyzes the collected data to determine how learners respond to the different type of innovative services. The method can be used by educational institutions to improve the ways in which they deliver training and ensure that their methods are effective and meet the needs and preferences of learners. The additional capabilities of the method to predict and assess change in preferences towards innovative services allow for a more accurate decision. The analysis can be useful to identify the most popular and effective innovative services and how they can be used to improve the learning process. It can also support optimal decision making by the management of educational institution, and with some minor modifications, the presented method can be adapted to determine the level of preferences of individual services, resources, technologies, and approaches in different domains, including to determine the degree of digitalization of educational institutions. Thank you for your attention.
Thanks for your presentation. Dear participants, do you have any question about this study? Okay, no questions. Thank you again. I wish you success in your career, dear Aldeniz Ashto.
Thank you.
Dear Mia Mohammed Asif Said, are you ready to present? Dear Mia Mohammed. Dear Yağmur Serenay Selçuk.
Yes, I'm here.
Okay, if you are ready, you can start your presentation.
Yes, okay.
You have 10 minutes, please.
But now I cannot share my screen.
Okay, please wait a while. Okay, you
Thank
can
you.
share your screen.
You can see, right?
Yes.
Okay, hello everyone. My name is Yağmur Serenay Selçuk. Today I'm talking about advancing home healthcare through machine learning, predicting service time for enhanced patient care. This is my outline. First, I will explain importance of the home healthcare and machine learning and what we contribute to the literature. Then I will show our data features and I will explain pre-processing and the data analysis part. Then finally, I'm summarizing what we did in this paper. Home healthcare refers to a range of medical and non-medical services provided to individuals in their own homes, and it is designed to support patients who may have medical conditions, disabilities, or chronic illnesses and require assistance with their healthcare needs. And home healthcare services are typically delivered by a team of healthcare professionals, including nurses, therapists, home healthcare aides, and other specialized caregivers. In the literature, generally, they are called caregivers or nurses. In this paper, we present an analysis of the data given by a home healthcare provider. We employ machine learning techniques to uncover the relationship between the features and the duration of the service time. K-means cluster technique is applied to better understand and analyze the characteristic of patients receiving home healthcare services. And we apply the elbow method and Sylhetto analyzing method to find the optimal K value. And this study aims to establish a correlation between various data attributes and the service time, enable healthcare providers to improve their service quality and efficiency. Predicting service time in home healthcare is critical for efficient resource allocation, scheduling of staff and the equipment, and the planning routing of the staff, which can directly impact the quality of care provided to patients. And accurate service time prediction can help ensure that patients receive timely and appropriate care, leading to better health outcomes and the higher patient satisfaction. And this study inspires by real data obtained from a home healthcare institution. The data set utilized in this study comprises 2,800 observations, each containing 15 features, including the patient ID and one target variable, which is service time. And the data set consists of both categorical and the numerical variables. Based on the available home healthcare data, the minimum and maximum ages of registered patients in the system are 3 and 95 years, and with a mean age of 75 years. This finding underscores the fact that the elderly population generally receive home healthcare services. And moreover, the data indicate that the minimum service time is 5 minutes and the maximum service time is 45 minutes. And the average service time is 14 minutes respectively. And due to the confidential agreements, comprehensive details cannot be revealed, unfortunately. Missing values refer to the absence of data in certain observations or variables within a data set. There are a total of 874 missing values in 3 different features our data set. In some cases, eliminating rows or columns with missing values may be a viable option if the missing data is deemed insignificant or if it introduces biases that comprise the analysis. However, the complete removal of the missing values can lead to a loss of potentially valuable information, especially if the missing data is not random. Due to significant amount of patient-related information present in our dataset, the decision has been made to refrain from excluding missing values. Instead, imputation techniques will be employed. In addition, duplicated values occur when there are identical observation or records in a dataset. In our dataset, there is no duplicated data, so we are lucky. To facilitate data analysis, histograms are employed to visually represent the distribution of features. During home health care, blood is taken from some patients to measure values such as cholesterol and blood value. Figure 4 shows that patients who are applied blood testing and 1 represents patients are applied blood test and 0 does not. It is predicted that caregivers will spend more time in the homes of patients who have had blood tests. Some
Fazla
of the
benim
patients,
şeyde.
some of the patients receiving home healthcare services are bedridden or disabled patients. Therefore, more than one caregiver serves such patients at the same time. Moreover, figure 5 shows that the distribution of patients served by more than one caregiver, and 0 on the x-axis represent that only one caregiver provides services and 1 represents that 2 caregivers service at the same time. Again, it is predicted that the service period of the patients who are served by 2 caregivers at the same time is longer. Figure 6 shows that the distribution of service times of the patients receiving home healthcare services. It is seen that the service periods of the patients is intense in the range of the 5 and the 20 minutes. As a result, the graphical representation examined provide insight into the potential relationship between the patient characteristic and the service time. By considering these graphs, predictions can be made regarding how these characteristics may impact the duration of service provided. For more detailed analysis, we apply the K-means cluster to the features. It aims to partition a data set into distinct groups or cluster based on the similarity of data points, where each point belongs to the cluster with the nearest mean. In this part, our K-value is equal to, for example, table 1 displays the percentage distribution of 2 clusters, which are the cluster 0 and the cluster 1, across different features. For instance, for gender feature in cluster 0 represent the male, 51% of the individuals are classified under the cluster 0, while 49% are classified under cluster 1. These are the female cluster. These are the same. In order to better understand the age distribution, the K-mean cluster method is applied, and initially the K-value is analyzed to be 15. As seen in figure 7, the most of the clusters are quite dense after the 60 years of the age, and it is expected. However, to understand whether the number of cluster is correct number, the optimal K-value should be found. First, the elbow method is applied to find the optimal K-value. As seen in figure 8, breaking starts on the graph from K is equal to 3, but within cluster, sum of squares value approaches 0 from K equals 5 value. For the elbow method, K is equal 5 can be optimal value. Then we apply the Silhetto method. According to Silhetto method, when K is equal to 3 is a global optima, and K is equal 5 is a local optima point, as seen in figure 9. Hence, it can be interpreted that the approach is yielded outcomes that are not substantially divergent from those obtained throughout the employment of the elbow method. As a result, we can say that the K-value can be taken as 5 in the K-means method to apply the age distribution cluster of the patient for the home healthcare dataset. To understand how variables are related to each other, whether they have a positive or negative association and the strength of their relationship, correlation matrix is developed, and we accept the p-value as 0.05. For example, any illness and age feature, our p-value is 0.4, and there's a highly positive correlation between any illness and the age feature. Hence, as the age of the patient increases, the probability of having a chronic disease increases as well. And the 2 caregivers and age features, our p-value is 0.05, so we can say that there's a positive correlation between 2 caregivers and the age. So as the age of the patient increases, the probability of serving the patient with 2 caregivers increases as well. Our target variable and the age feature, p-value is 0.2. There's a highly positive correlation between service time and the age. So as the patient gets older, the length of the services increases. So we can say that age is a very significant value for determining the service time. And the lab investigation and our target value, p-value is 0.1. There's a highly positive correlation between lab investigation and the service time. So as blood tests are taken from patients, the length of the service time increases. So again, lab is another important feature for determining the service time. And lastly, any illness and target value, p-value is 0.06. Again, there is a positive correlation between any illness and the service time feature. In other words, if patients have a chronic illness, this causes an increase in the service time. So this is an important feature as well for determining the target value. So as a result, this paper analyzes data obtained from a home healthcare provider, focusing on understanding the relationship between the different feature and the duration of the service time. Through applying machine learning techniques, particularly the K-means cluster technique, we gain insight into characteristics of patients receiving home healthcare services. Additionally, we employ the elbow and stiletto methods to determine the optimal K-value for the clustering. The ultimate goal of this study is to establish correlations between various data attributes and the service time, empowering healthcare providers to enhance the quality of the efficiency of their services. By leveraging these findings, healthcare providers can make data-driven decisions and improvements that lead to better patient outcomes and overall enhancement of the home healthcare experiences. Thank you for listening. Keep calm and analyze the data and stay healthy.
Thanks for your presentation. Dear participants, do you have any question about this study? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Dear Ömer Kayan, are you ready to present?
Yes, I'm ready to present.
Okay. If you want, you can start your
Yeah.
presentation.
Do you see my screen now?
Yes.
Yes. Hi, everyone. To quickly introduce myself, currently I am working as an industrialization engineer at ASML Netherlands in the semiconductor industry. I will complete my master degrees in mechatronics engineering at Istanbul Technical University at the end of this semester. Today, I will present our study, which is done by myself, Ömer Kayan, and by my professor, Hülya Yalçın. In this paper, deep reinforcement learning method, which imitates the reference walking motion, is used in the simulation for musculoskeletal model to learn to walk. The walking performance and the muscle activation of 4 different models that are healthy, and the second one is injured in the knee but not wearing an orthosis, and the third one wearing passive orthosis, and the last one wearing active orthosis are compared. We started this study by considering the human musculoskeletal structure. In particular, we focused on the bones and the muscle structure that directly affects the knee area. In the picture, you can see the femur bone here, patella bone, and the tibia bone, and the muscle tendon units. Since we were working on the knee orthosis, we have done detailed research on the knee joint and the knee injuries. Knee joint is the largest and the most complex joint in the human body, and the knee muscles are the most energy-consuming muscle group after the hip muscles. And the knee area can be loaded up to 3 times of body weight. And as a result of the classification of injuries, the knee emerged as the region with the highest number of injuries and the most expensive treatment cost. The knee joint area, which is already complex in structure, can become even more complex after injuries. Various injuries occur due to movement for daily routines, impulses during sports, arthritis, or aging for people. Orthoses are generally classified into 2 categories as passive and active orthosis. In passive orthosis, the mobility either does not go beyond the preset range and there is no movement at all. Active orthoses support the body, and the active orthoses support the body in a more stable way by constantly updating the range of motion and the sensors with the sensors and actuator on it. Depending on the technological developments in the recent years, musculoskeletal system simulations are preferred to estimate the effects of the assistive device, such as orthesis and prosthesis on humans. The significant benefit of the simulation is that the applications that are risky in the real life can be done easily in the virtual environment. They also allow for easier measurement for crucial indicators such as muscle strength, torque values in the joints, thus providing estimations against the possible bad situations. In addition, different injuries can be simulated as well. Finally, it can be adapted according to the patient by changing the variables of the people, for example, weight, height, muscle strength, etc. The simulation environment is based on the learning of the model, which consists of the skeletal parts and the muscles by imitating the reference motion, and this environment is taken from the study of the Lee and his friends. The model has 284 muscle tendon units, and there are 23 different joints on it. One of them is the knee joint. It's a revolute type of joints with 1 degree of freedom. In this study, as you can see in the pictures, the walking performance and the muscle activations of 4 different models are compared. The first one is healthy model, MH. MI is injured in the knee but not wearing orthesis model. And MP is the injured and wearing passive orthesis model. And MA is injured and wearing active orthesis. And for MI, MP, and MA have these injuries in the left knee area. The muscles in the knee area are weakened and the bone deformity has occurred. To be able to make a fair comparison, all 3 models are injured exactly the same. The passive orthesis is designed to apply a constant person torque to joint of the knee through the walk. In general, passive knee orthesis absorbed 18% of the force and also 2.7% of the torque in the knee during the various athletic movements. In this study, the calculation are based on these percentages. Active orthesis can be used to compute the necessary torques of extension and the flexion of the knee joint to perform desired motion in dynamic simulation environments. And the active orthesis apply torque of different magnitudes to knee joint at each step of the dynamic simulation. Active orthesis should be able to provide up to 60% of 60% of the person's gait cycle peak torque, and in this study the calculation are based on these percentages as well. In this slide deck, I want to introduce my design controller. The section on the left side, as you can see, is the open source simulation environment in the work of Lee and his friends. In here, trajectory mimicking compares the position of the body parts with the corresponding positions of the motions given as a source, and it tries to estimate the trajectory to the close the difference resulting from the comparison. In order to follow the predicted trajectory, the process of estimating which muscle group will be activated at which activation level is the task of muscle coordination. At the right hand side, you can see my active orthesis controller. It's designed to match the frequency of the dynamic simulation. First, it reads values from the dynamic simulation which are taken from the healthy model MH. These values are head neck joint, tibia ground angle, left hand angular velocity, and angle joint angle. And the values feed the inputs of the artificial neural network. The neural network estimates the knee joint angle, and the estimated values are filtered by low-pass filter. The low-pass filter is applied so that the extreme values that may occur after the estimation do not affect the smoothness of the motion. The torque in here, the torque value required for the MA model to instantly reach the targeted knee joint angle is calculated with the stable PD controller. Stable PD controller is a method that increases the stability of the controllers by calculating the next simulation step in the dynamic simulation environment. Also, at the right-hand side, you can see the angles where they are coming from. Before moving on the experiments and the results section, I would like to talk about the gate cycle as well. Here we see the one gate cycle of my MA model. It consists, the gate cycles consist of two main phases, namely stance and swing. Here we can also see the different subphases. I want to talk about the experiment and result now. Each model's walking training took approximately 56 hours. The model that achieves the highest reward in the training environment is considered the most successful model. As expected, as the result of the comparison, the model MH model produced the most successful result. Active orthosis wearing model MA is coming afterwards. MP passive orthosis model and also coming afterwards. And the most unsuccessful one was the MI. It was not wearing the orthosis. Also, comparison of the walking performance on the reward was also made in the simulation environment as well. Here we can see the amounts of rewards that the models collect during the walking cycle. The model that achieves the highest average reward in the simulation environment is considered again most successful one. As expected, as a result of the comparison, the healthy model MH produced the most successful simulation result. Active orthosis wearing one MA model is coming afterwards, and then MP, and the most unsuccessful one again was MI model. Comparison were also made on the walking behaviors. It has been stated the model MH walking closest to a normal healthy person. This was followed by model MA. Also, the model MI, the injured one, on the other hand, occupied the 5 different lanes on the tiles in the picture, as you can see. Also, there were so much swing, and there were so much swing during the walk. Finally, comparison were made over the activation level of important muscles in the knee region as well. I wanted to show 3 different muscles as an example here. Now, I want to interpret the results for all the muscles in the knee area. As I said, I want to interpret the muscle activation results in this table. On the left-hand side, we can see the muscle group name. And its right, we can see the muscle name. As a result of the comparison, the model MH produced the closest muscle activation value to the normal healthy person for all muscles as expected. The model that produced the second closest value to healthy person varies, but for many, this was also seen that the second most successful model is MA. This is followed by MP and MI injured man models, respectively. And I conclude my presentation here. Thank you all for your interest. If you have a question, remarks, feedbacks, I'm here to answer them.
Okay, thank you for your presentation.
Thank you.
Dear participants, do you have any question about this paper? Okay, no questions. Thank you again. I wish you success, dear Ömer Kayan,
Thank you all.
in your career. Dear Nahid Hassan,
Yes, I'm here. Can you hear me?
okay, are you ready to present?
I'm ready. Start.
Okay, if you want, you can start your presentation.
Hello everyone, welcome to our presentation. Our paper ID is 213, which is implementation of Bangla extractive update summarization task on view some BNLP dataset, a multi-document update summarization corpus. I'm Mohammad Nahid Hassan, author of this paper, and my co-authors are Rafsan Bari Shafin, Marokar Nurtaj, Jisan Ahmed, Mohammad Saddam Hussein Khan, Rashidul Amin Tuhin, and Mohammad Mohsinuddin from the Department of Computer Science and Engineering of East West University, Dhaka, Bangladesh. This is the overview of this presentation. You may ask, what is actually automatic update summarization task? Automatic update summarization task is a system which aims to provide latest and updated information to the user. Suppose any natural disaster like earthquake, floods, or cyclone occurred. By the time informations are so vague and it's hard to get the information correctly. In this case, automatic update summarization helps to get the updated information over time to the user. And nowadays, people are so busy, they do not have enough time to read long documents to get the information rather than getting it in a shorter form. And for this, update summarization is very effective. And Bengali is a very rich language in terms of vocabulary, but it lacks enough research fields and developers. That's why we thought to contribute to Bangla ML and NLP sector. And while researching this problem, we have gone through a lot of articles and research paper and gathered knowledge to solve our problem. And 3 of them is here. And first one, author used 3 steps to make multi-document summarization, like pre-processing, sentence extraction, and post-processing using MMR method. And the second one, author used TF-IDF model to improve their accuracy. And the last one, the author used supervised model using integer linear programming for update summarization task. And to do this work, we have created a dataset called ViewSum BNLP dataset. And while making this dataset, we have considered so many things, like while taking the news, we maintain that it's coming from the authentic news source. And we also pre-process the text properly before creating human-generated summary. And we followed a guideline to make summary smaller, and also gave guideline to the annotators who review our summary. And also we never bias to any community and maintain ethical issues while making this dataset. And to extract data, we used web crawler, which is called Beautiful Soup, to extract information from different kind of links, and we sequence them based on their date time. And in our dataset, there are total 60 topics and 120 human-generated summary, splits into 6 categories, which are international, sports, politics, entertainment, Bangladesh, and business. And each topic has 2 sets of folder, A and B, and each folder contains minimum 3 to maximum 5 documents, including title, date time, keyword, human-generated summary, and model-generated summary. And all those documents were sequenced as old to new order. Here is a visual representation of our data set. Here you can see in the left side is the folder, and then if you go to the document, there will be 120 topic, and if you go further to the document, there will be two folder A and B, then text, then the formation of the text, and also the keyword will be there. Here is a overview, is a diagram of a single topic, as you can see here. And this is a visual bar chart of the length comparison of the document and human generated summary, which shows how short our summary is compared to text document. And for this task, we have used two models, which is sentence rank and TF-IDF based model. And first, in the sentence rank model, we remove the redundant information within the sentence by using cosine similarity function, which when a cosine similarity value of two sentences are close to 1, we call those similar sentences. After that, we fix the cosine threshold value at 0.7 for our particular model. If any two sentences cosine value are 0.7 or greater than 0.7, we eliminate the rest of the sentences, keeping 1. And after that, sentence string model used a BN send tokenizer function, where the input Bangla text is first tokenized into sentences. Then we used a trained word2vec model. Thus, the word embedding are calculated for each phrase, and then a matrix is created and filled with the estimated distance between the sentence vector. Then the distance matrix is converted into a diagram where the distance scores corresponding to the edges and phrases serves as the vertices and stored in a ND array. Next, the most frequent sentences are determined, and top 8 judgment are chosen to produce the review. And after the then tokenized sentences and sentence graph score used as input for a special method called extrasum, which produce the final summary. And the next part, the other algorithm, we have used the TF-IDF based algorithm, which is similar to sentence string model. It also you take multiple files as an input and checks from the database and from the inputted document that if there is any redundant information or not. If it finds any redundant information, our model will detect it, and with the help of cosine similarity and we remove the redundant information. After that, rest of the document will be transferred into the pre-processing part, where we used a tokenized model, which is called BNLP tokenizer, which is specially built for Bangla document, and then stemming the word to convert it into its raw form and remove the punctuation, stop words, and extra word digits, like something like that. After that, it create a word matrix from where it can visualize the count of the per word. With the help of it, it calculates term frequency and also calculate inverse document frequency. And after the frequency, we got our generated summary. After we generated the summary, we evaluated our model based on Rouge score, and we see that for every Rouge score, Rouge 1, 2, and L, our TF-IDF model overperformed the sentence rank model. Here is the side-by-side comparison of our human-generated summary and our model-generated summary, which shows that our model-generated summary is a very good form really, compared to human-generated summary. And we successfully implemented 2 cutting-edge models on our newly proposed ViewSum BNLP dataset. These datasets serve as the backbone of our research, enabling us to fine-tune our models to better level of accuracy. Through the experiment, we have crafted model-generated summaries that possess a remarkable ability to retain both relevance and accuracy, concurrency. And this is the reference we used for this presentation. And it's all about from us. Thank you.
Thanks for your presentation. Dear participants, do you have any question about the paper? Okay, no questions. Thank you again, dear Nahid Hasan. Dear Abdisamet Muhammed Ali,
Yes, sir.
You are ready to present?
Yes.
Okay. You can start your presentation, sharing your screen. You have 10 minutes, please.
And I hope my presentation is visible.
Yes.
Okay. And my presentation is analyzing of undergraduate student performance pattern and profiling potential dropouts. This is my bio. With the outline of the presentation, the background, the problem statement is objective and significant, literature review, gap analysis, methodology, data description, result, and discussion, the last conclusion. The background, student performance, its sex component in greater education institution predict and analyzing the overall performance of the scholar. It's imperative to aid educators figuring out weakness and bettering academic score. The important purpose in the back of this flag of research exploring one-of-kind prediction strategy and key attributes that have impacted the student academic performance. This study found that the classification computing device mastering algorithm used to most often used in predicting the success of student learning. The dropout and retention student has long been one of the most critical questions in higher education. Low retention and graduate rates of students could impact higher education institutions in many different aspects, including their academic, their financial plan. Therefore, dealing with such critical issue is necessary through the strategic and plans that are based to do significant research finding. Further, it's important for higher education administrator, policy mark who seek solutions to such problems understand that the background of dropout phenomena of students and the most common factors that cause students to leave their study program without completion. The problem statements of the title or the research, large of number of students drop out the university of each year in a different reasons, with a different reasons. Also, dropout face host negative outcomes due to their failure and to graduate. Dropout have a higher unemployment rates, lower earning, poor health, and higher mortality rates. Also, dropouts, high rates in criminal behavior, increased reliance of public assistance compared to high school graduate. Research objectives to determine if the gaining knowledge of models has been feasible as a way of figuring out college students prone to failing in Jumuria University. To decide who yearly route is the feasible, appropriate, or appropriate to make this predicting in a Jumuria University also. This project is beneficial to academic lecturers, managers, university projects, university. These projects help academic and managers given to track students' status. Further, by studying into how yearly grade impact student performance, there have also been significant number of studies into correlation between degree exam or performance and student general background in the affirmative to determine which factors have a direct effect outcome of students' learning. The literature review of my research, we found quite few literature reviews that examine the academic education performance modeling in distinct views. Some of the literature reviews, the higher education empirical lookup of people attention relies upon the availability of true data. There are two kinds of that have been exploited in the literature. Administrative factors and certify that due to lack of handy administrator, that information and scholars' attention in a German university of mostly gathering from the survey. Student dropout desired because abdominant of executive schooling software ailing the acquiring the diploma with other recognition enhancement that impacts each better schooling institution in predicting one of two scholars no longer graduate. This also for the literature review as a tabular form. Two slides that literature review for slided form, gap analysis and contribution. The evaluation of the above literature infers the sequence of study gap. They may be information on college student statistics for every route seeking to recognize that sort of scholarship by determining of what sort of a publication. The major drawback of period study, and there were so many algorithms examined that it was difficult to identify the general types of standardization parameters operate the algorithm determine that is the most effective in this instance random forest k nearest and decision tree. This study explored fusion of factors that possibly have impacted the predicting and pattern juice of application. The goal of this work to overcome Joyce markers within the predicting and patterning managing control better known who element which may acquire correlated with predicting process. For this purpose, we used real data for student resulted at University of Mogadishu, Jamhuri University, as a case study in Jamhuri University representative that variety of regional comprehensive university, and thus the result of this work could be widely applicable to other university. This study found that the classification competent device mastering algorithm used to be the most used of predicting success in student learning. The algorithm that had been used to extra frequently the predicting learning about the people sex are k-nearest, neighborhood, recall score, precision score, random forest, and SVM and decision tree. Meanwhile, the record is used in this research article is predominantly classifying student sexes in mastering into two or three classes, which are pass or veil, or veil pass or pass or excellent. Data description. The statistics for the tests got have from Jamhuri University Technology Learning Analyzing Statistics set which incorporate anonymous statistics from 20 to 22 semesters publications, which include that private details evaluation markers done its course almost the routes and the whether not bubble based or valid dropped from the selected routes. These are my research methodology at Carter. First, coming data set, data processing, feature extraction, machine learning modeling, machine learning algorithm, classifiers, data classification, and the last result. Result and proposal. Student performance is the sexes component in greater education institutions. Predicting and analyzing overall performance of the scholars imperative to aid educators in a figure weakness and bettering academic scores. However, a combination predicting is a challenge due to the large of quality instructional data. The important purpose is the back of this large research exploring one of kind predicting strategic attribution that have impacted student academic performance. This is the result is the k-nearest prediction, recall, and best score. Almost the decision tree, prediction, recall, and best score. Random forest, also linear, SVMs, prediction, precision, recall, and best score. Based on the outcome, research got research improving overall performance. P models like linear, SVM, and KNN are compared to the previous study, and additionally giving all models that have a chance to go the race. Some snapshots of the results. These are status for the student status. You can get the snap of like 67% of students are almost inactive or dropouts. That problem we need to solve it. What kind of problem? When comes of the problem? When every time or when students absence increase, the average of students decrease. When student absence decrease, the average in students will increase. This chart will show you. Conclusion: the overall goals analyzing, design, implement system provide instructors and students valuable profiling with goal to cut back to dropout rates. The amount of your time student performance analyzing profiling potential dropouts can be to analyzing every student performance that the personal data building models which could predict student grades in the future form their current performance, which initial or second week of the course in establishing poor performing student really ill with this course. We need this the future like work or real database with machine learning to make enhance student performance or analyzing student performance, and that is the methodology. Thank you for any question.
Thanks for your presentation. The
Thank
participants do have any question about this study?
Thank you.
Okay, no questions. Thank you again. I wish you success, dear Abdulsamet Muhammad.
Thank you.
Dear Hasan Tolga Ünal.
Merhaba.
Hello. Are you ready to present?
Evet, ben Türkçe sunacağım bu arada izninizle.
Okay, okay.
Şimdi ekranımı paylaştım. Umarım görünüyordur şu anda.
Okay.
Evet, merhaba. İsmim Hasan Tolga Ünal. Havelsan Bilgi ve İletişim Teknolojilerinde çalışıyorum. Şimdi Havelsan kendi içerisinde 3 farklı çalışma odağına sahip ve Türkiye'nin en büyük yazılım entegratörü konumunda olan bir yazılım firması. 3 farklı çalışma odağına sahip ve ayrı birimler olarak faaliyet gösteren bir şirket. 2000'den fazla personeli ve ekosisteminde 750'den fazla şirkete sahip. Tabii bizim çalışmamızın bulunduğu odak bilgi ve iletişim teknolojileri, inovasyona ve veriye çok önem veren bir yapıya sahibiz ve veri odaklı yetkinlikler gelişmiş, uzmanlaşmış durumdayız. Küresel ölçekte yazılım entegrasyon misyonu edinmiş ve savunma sanayiye ek olarak sivil kullanıma da oldukça verimli ürünler ve çözümler geliştiriyoruz. Yetkinliklerimiz bu alanda görüntü işleme, açık kaynak, nesnenin interneti, biyometrik veri, siber güvenlik gibi, dijital dönüşüm gibi oldukça geniş kapsamlı. Biz de bu yetkinliklerimizin uygulanabileceği ve verim elde edebileceğimiz süreçlerde katma değerli çözümler geliştiriyoruz. Şirketten bahsettikten sonra çalışmamıza geçelim. Zamanla gelişen teknolojik bilgi birikimi ve toplumsal yaşam tarzını benimseme, şehirlerde daha yoğun bir insan yaşamını da beraberinde getiriyor. Özellikle refah kaygısı, imkanların bolluğu gibi sosyolojik konularda şehirler kırsal yerlerden daha cazip. Bu bağlamda şehirlerimizde artan nüfusla birlikte hacmini genişleten bir toplu taşıma faaliyeti olduğu bariz. Ulaşımın bu denli bir ihtiyaç haline gelmesi sebebiyle günümüzde de popüler olarak toplu ulaşım metotlarının en yoğun şekilde karayoluyla kullanıldığını görüyoruz. Dünyanın pek çok yerinde. Şimdi burada özellikle otobüslerin çok ön planda olduğunu analiz ettik. Ancak otobüslere olan talebin artması ve otobüs sayısının artması sistemin ve akışın kontrol edilememesini de beraberinde getiriyor. Yani yolcuların daha yoğun otobüslerde seyahat etmek zorunda olması, sürücülerin çeşitli kurallara itibar etmemesi ve bu disiplinsizlikten kaynaklanan trafik güvenliğini tehdit eden bir yapının oluşması esasında çok ciddi bir sorun haline gelmiş. Bu konuya yönelik olarak birçok talebi değerlendirdiğimizde bir analiz yapıp bir çalışma başlatmamız gerekti. Şimdi problemi tanımlamak için şehir genelinde faaliyet gösteren kurum ait otobüslerin herhangi zamanlardaki kondisyonlarını inceledik ilk olarak. Bir istatistiksel bir analiz yaptık yani. Toplamda analiz ettiğimiz otobüs sayısı 743. Bu otobüslerdeki anomalileri istatistiksel modellere çevirdiğimizde karşılaştığımız tablo oldukça dikkat çekici. Şöyle ki sürücü anomalisine odaklandık çünkü problemlerin %80'i sürücü anomalisinden kaynaklı esasında, bunu da belirteyim. Bu bağlamda 380 sürücünün araç kullanımı esnasında sigara içtiğini seyir halindeyken, 355'inin emniyet kemeri takmadığını ve 365'inin de yine seyir esnasında cep telefonu kullandığını ve cep telefonuyla konuştuğunu fark ettik. Ayrıca bu durumları eş zamanlı yapan sürücülerin sayısı da hiç az değil. Mesela sigara içerken emniyet kemeri takmayan 189, sigara içerken cep telefonuyla konuşan 186 ya da emniyet kemeri takmayıp cep telefonu kullanan 166 adet sürücüye rastladık. Ayrıca 3 durumu eş zamanlı olarak uygulayan 88 adet sürücü tespit ettik. Bu tespitlerin tek bir merkezden canlı olarak ya da geriye dönük olarak hatasız tespit edilmesi gerekiyor. Yani sürücünün anomali davranışlarından uzak durması için sürekli bir merkezi kontrolü sağlanması gerektiğini fark ettik. Bu bağlamda Havelsan'ın sahip olduğu görüntü işleme yetkinliği doğrultusunda bir çözüm üretilebilir. İnsan gücünü kullanmayan ve hataya yer vermeyen bir yapay zeka uygulamasıyla tek merkezden ihtiyaç duyulması halinde geriye dönük olarak yine yapay zeka ile analiz edebilme yetenekleri kullanılabilir olduğunu gördük. Tabii ekiplerimizce yaptığımız analizler neticesinde değerlendirmemiz gereken teknolojilerin başlıca kapalı devre izleme, closed circuit television, CCTV ve yapay zeka temelli bilgisayar görü, computer vision başlıkları olduğunu saptamış bulunuyoruz. Kapalı devre izlemeyle otobüslere bir IP kamera altyapısı kuracağız. Ve kurumun kamera odasına ya da merkezi izleme noktasına tüm görüntülerin canlı olarak aktarılmasını, ayrıca burada depolanmasını güvenli bir şekilde kurulan altyapı aracılığıyla bilgisayarlı görü computer vision teknolojisi çalıştırılarak istenmeyen durumların tespitini, anomalilerin tespitini yaparak merkezi arayüzde alarm üretme sistemini tasarlamamız gerektiğini fark ettik. Ancak bu sistemin temelinde yatan teknolojiyi iyice anlamamız lazım. Bu hizmete yönelik ürünler ortaya koymamız lazım. Şimdi öncelikle sistemin omurgasını oluşturabilmek için bir kapalı devre izlemeye dair birkaç analiz yaptık. Buradaki sistem mühendisi otobüsleri bir edge device olarak gören ve bu edge device'larda kendi içerisinde bir habitat oluşturan kamera altyapıları kurmak olarak ortaya çıkıyor. Yani her otobüs içerisinde sürücüyü görecek birkaç IP kamera, network'e bağlı kamera. Bu IP kameralarında otobüs içerisinde bağlı olduğu ve görüntüyü kaydettiği bir kayıt cihazı konumlandırılması lazım. Ancak hala merkezi yönetim problemini çözemiyoruz. Yani uçta analiz yapmış oluyoruz. Bunun için de kameraların bağlı olduğu kayıt cihazlarına bir erişim oluşturulması lazım. Bunu da nasıl yapacağımızı araştırdığımızda donanım bağımsız bir şekilde filo büyütülse de yani yeni eklenecek otobüslerde de kullanılabileceğini öngördüğümüz için API, uygulama programlama arayüzüyle bir iletişim sistemine tabi tutulması konusunda mutabık kaldık. Şimdi kayıt cihazlarına API ile merkezden bağlanan bir arayüz üzerinden tüm kameralar görüntülenmeli, kontrol edilebilmeli, seslerine erişebilmeli. Hatta geriye dönük kayıtlara da erişebilmeliyiz. Şimdi bunun için de merkezi bir yönetim sistemi ürünü oluşturduk ve adı günümüzde Orbit olarak belirlenmiş durumda. Orbit şu anda 100.000 kameraya kadar herhangi bir marka ve model kayıt cihazına API ile bağlanarak herhangi bir gecikme olmadan ve tutarlı band genişliği sağlayarak merkezi istemcide konumlandırılan bir yazılım olarak gün yüzüne çıkmış durumda. Şimdi işin yapay zeka tarafının da çözüme kavuşturulması gerekiyor. Orbit üzerinde merkezi arayüzde yapay zeka çalıştırmak ve alarmların bu arayüze görüntülenmesini sağlamak için entegre bir computer vision yazılımı oluşturmamız gerekiyordu. Ancak burada yapay zekanın nasıl değerlendirileceğine ilişkin tarama yaptığımızda öncelikle görüntü toplamamız ve analiz etmemiz gerektiğini gördük. Yani esasında bilgisayarın tıpkı bir insan gibi görüntü üzerinde nesneyi görmesi ve ayrıştırması için bir train sürecine ihtiyacımız olduğunu gördük. Bu bilgisayarların görsel girdileri anlamalarını, bunlara dayalı olarak eylem yapmalarını ve önerilerde bulunmalarını olanak sağlayan bir sistem. İnsan gözlem yetenekleri gibi bilgisayar görüşte nesne tanıma, mesafe tahmin etme, hareket algılama, görüntülerdeki anormallikleri tespit etme gibi işlevleri gerçekleştirmesine olanak tanımak için öncelikle neyin ne olduğunu öğrenmeliydi. Burada CNN dediğimiz Convolutional Neural Network sisteminden, yapay zeka, deep learning modelinden faydalandık. Tabii evrişimli sinir ağları diye Türkçesi. CNN ile görüntüleri katmanlara ayırarak tespit etmek istediğimiz görüntü unsurunu ön katmana taşıyarak bir labeling, işaretleme metoduyla çalışma yaptık. Böylece train ettiğimiz yapay zeka modelinde sigara, cep telefonu ve emniyet kemeri durumları günümüzde %90 ve üzeri başarı oranında tespit edilebilir duruma geldi. Merkezi arayüzde eş zamanlı analiz için merkeze konumlandırılması gerekli olduğunu gördük. Ve merkezi bir yapay zeka yazılımı olarak oluşturduk ürünümüzü. Bu yazılımda ihtiyacı özel bilgisayarlı görünüm modellerinin yüksek başarını geliştirme süreçlerini sağlamasıyla iMiner adını aldı ve Havelsan'ın bilgi ve iletişim teknolojileri ürün portföyüne eklenmiş bulunuyor. Şimdi iMiner günümüzde bu maddeleri %85-90 ve üzeri başarı oranıyla canlı ve geriye dönük kayıtlarda tespit edip merkez arayüzde alarm üretebiliyor. Tabii çalışmamızın nihayetinden itibaren geçen süre neredeyse 1 yıl oldu. Artık kolaylıkla otobüslerin kondisyonlarını hiçbir insan eforu olmaksızın takip edebiliyoruz. Ve sadece 2 adet ürünle bunu gerçekleştirebiliyoruz. Bu ürünlerin proje sürecinde konumlandırılmasıyla birlikte yaşanan gelişmeleri de slide üzerinde zaten görüyorsunuz. Yani sigara kullanımında, emniyet kemerinde, hatta sigara ve emniyet kemeri anomali durumunda 0, emniyet kemeri ve cep telefonunda 0, tüm anomali durumlarının eş zamanlı olarak işlenmesi durumunda 0 sürücüye ulaşmış bulunuyor sistem. Tabii buradaki anomalilerin alarmlarına yönelik sürücülere yaptırımların ağırlıklandırılması, weighted modelingin uygulanması gibi detayların getirmiş olduğu farklılıklar da bulunuyor olabilir. Ancak sistem tüm durumlarda inanılmaz bir iyileşme sağlandığını bize gösteriyor. Tabii bu sistem sadece otobüsler üzerinde olmamakla birlikte birçok sivil uygulamada implement edilebilir durumda. Yani ürünlerin hazır ve kolay entegrasyona sahip olması uygulama süreçlerini oldukça kolay ve ölçeklenebilir hale sokuyor. Bu bağlamda Havelsan bilgi ve iletişim teknolojileri olarak yeni görüntü işleme konseptleri üretiyoruz ve üretmeye devam edeceğiz. Yani çok büyük bir pazar. Bu şekilde talep edilen durumların anomaliden uzaklaşmasını ve insan hata payını minimize eden computer vision teknolojisinin en kolay şekilde yaygınlaşmasını hedefliyoruz. Beni dinlediğiniz için teşekkür ederim.
Thanks for your presentation. Dear Parsim, do you have any question about the study? Okay. Dear Hasan Tolga, you can start your second presentation if you are ready.
Tamamdır, açıyorum şimdi. Evet, bir sonraki çalışmamız Web 3.0, Applications ve Projections başlı çalışma. Şimdi internet üzerinde yazı, görsel ya da işitsel herhangi bir veri aktarımını web sayfaları aracılığıyla yapıyoruz. İşte burada bir ağ oluşuyor ve bize dokümante ederek ağ üzerinde sayfalar meydana getiriyor. Bu yapıya web adını veriyoruz günümüzde. Ayrıca tabii ki internet teknolojinin gelişmesiyle paralel olarak web'in çeşitli kırılma dönemleri olduğunu da görüyoruz. Yani 1.0, 2.0 ve 3.0 olarak adlandırdığımız günümüzde çeşitli kırılma dönemleri var. 3.0 anlamak için 1.0 ve 2.0'a bakmak gerekiyor belki. 1.0 aslında bilgilere erişimi sağlamak için tasarlanmış statik web sayfalarının kullanıldığı dönem. Yani içerik bir sunucunun dosya sisteminde bulunuyor. Ve herhangi bir kullanıcı etkileşimi bulunmuyor. Yani bu sadece internet okuyucularının olduğu bir dönem olarak, okurlar dönemi olarak geçen bir dönem. Web 2.0 biraz daha farklı olarak kullanıcı girdileriyle şekillenen dinamik içerikleri de barındırıyor. İşte sosyal medyada etiketleme, yorum yazma, blog yazma gibi kullanıcı etkileşimlerinin mümkün olduğu dönem. Bu döneme de kullanıcıların içerik oluşturduğu dönem, yani kullanıcı etkileşimi dönemi olarak tanımlanıyor. Şimdi Web 3.0 terimi biraz daha dağıtık, merkezi olmayan ve bir çevrim içi ekosistem olarak tanımlayabileceğimiz bir kavram esasında. 1.0 ve 2.0'dan farklı olarak 3.0'ı biraz daha iyi anlayabilmek için ekosistemin yapısını oluşturan teknolojilerin ne olduğuna bakmakta fayda olduğunu düşünüyoruz. İlk olarak bu noktada dağıtık özelliğini ele almamız lazım. Blockchain teknolojisiyle elde edilen değerli veriler merkezi bir veri tabanında depolanmazlar. Dağıtık ve bağımsız veri tabanlarında bulunurlar. İkinci bir özellik olan güvenlik konusunda yine blockchain teknolojisi verilerin tam güvenliğini sağlarken aynı zamanda otoritesiz dağıtılmış uygulamalarda kullanıcı etkileşimine imkan tanıyor. Diğer üçüncü bir özelliğimiz anlamsal yaklaşım. Yani yazılım adeta insan gibi bir yapay zeka ya da machine learning teknolojisiyle web içeriklerini yorumlayabilir ki bugün ChatGPT gibi çok ciddi bir örneği bulunuyor. Son olarak da evrensellik, evrensel ölçek, IoT, nesnenin interneti teknolojisiyle cihazlar doğrudan internet bağlantısı aracılığıyla uzaktaki sunuculara etkileşimde bulunabiliyor. Yani Web 3.0 kavramının blockchain, AI, yapay zeka ve IoT gibi inovasyon odaklı teknolojilerin birleşimiyle ortaya çıktığını aslında görüyoruz. Şimdi merkezi ve dağıtık uygulamalar arasındaki farkları ele almak faydalı olacak. Öncelikle merkezi teriminin açıklamasına geçmeden önce bunu tanımlarsak, verilerin ve platformun işlevlerinin bir otorite tarafından kontrol edilmesi. Yani tek otorite tüm kontrole sahip aslında. Hani günümüzde zaten tanıklık ettiğimiz klasik bir sistem. Diğer yandan dağıtık teriminin anlamı verilerin tek bir otoritenin birden fazla bağımsız otorite tarafından kontrol edilmesi olarak tanımlanabilir. Yani birçok otorite tüm bilgiye sahip bir şekilde, güvenli bir şekilde aynı şeyi paylaşıyor. Şimdi günümüzde blockchain aslında en popüler dağıtık defter teknolojisi dediğimiz dağıtık sistem teknolojisi. Merkezi uygulamalar aracılığıyla bankalar tarafından yönetilen hesapları, aracısız dağıtık uygulamalar aracılığıyla işte güvenli bir şekilde yönetmeyi mümkün kılmış bir teknoloji. Blockchain teknolojisinin finans dışındaki alanlarda da merkezi olarak yönetilen verilerin dağıtık uygulamalar aracılığıyla yönetilmesine olanak sağlayan potansiyeli zaten aşikar. Bu nedenle temelde kripto para birimlerinin altında yatan uygulama mimarisi genel bir adı olan dağıtık uygulama olarak tanımlanmaya başlanmış. Bu bağlamda blockchain ağları erişim açısından genel ve özel olarak iki kategoriye ayrılıyor. Şimdi genel blok zincirler herkesin erişimine açık olan blok zincirler. Burada birkaç temel kavram var. Hesap, işte kullanıcıyı tanımlayan, işlem, kullanıcının verdiği talimatı tanımlayan, düğüm, her verinin saklandığı veri noktasını tanımlayan, blok, işlem sonucunda zincirleme olarak birimlerin birleştiği unsurlar olan, yani işlem entegrasyonu ve zincirin birimini tanımlayan, yine mutabakat uzlaşı dediğimiz, konsensüs dediğimiz ortak protokolü tanımlayan, ortak anlaşmayı tanımlayan ve nihayetinde de akıllı kontrat olarak tanımladığımız blockchain üzerinde belli adresi bulunan kod ve veri koleksiyonları olarak bu çeşitli temel kavramlardan kısaca bahsedebiliriz. Şimdi bir diğer erişim tipine sahip blok zincir tipi de özel zincirler. Bunlar belli bir organizasyon içerisinde deftere işleme mantığında çalışan ağlar. Hani genelde amaç iş modeli geliştirmek oluyor. Yani bir işin akışını hızlandırmak, performans ölçütlerini ortaya koymak ya da kontrol edebilmek gibi amaçlarla kuruluyorlar. Özel zincir yapısını anlayabilmek için bir senaryo üzerinde bir bakış atalım istedik. Yani COVID-19 salgınıyla birlikte zaten yaygın bir şekilde kullanılan aşı sertifikası yönetimi senaryosu blok zinciri üzerinde gerçekleştirilen ve en çok konuşulan senaryolardan biri. Bilindiği gibi genel blok zincirlerinde tüm taraflar ağa katılabiliyor ya da ağ üzerinde işlem yapabiliyor. Özel zincirlerde işlemin güvenilirliğini garanti ederken hala tek otorite olduğu için işlem sahibinin güvenilirliğini garanti etmiyor. Aşı kayıtları bağlamında özel blok zincir, aşı kayıtlarının güvendiğimiz tıbbi yasal birimler tarafından oluşturulması gerektiği için buradaki ihtiyacı karşılamıyor. Yani yalnızca yetkili yasal kurumların doğrudan işlem yapabildiği ağlar, özel blok zincir ağlarına yönelik bir çözüm oluyor. Bu kullanım senaryosunda değerlendirilebilecek ilk yapı, işte Türkiye Cumhuriyeti Sağlık Bakanlığı gibi bir otoritenin kontrolünde olan bir blok zinciri ağ kurmak aslında. Ancak Sağlık Bakanlığı gibi tek merkezi bir otoriteye sahipseniz sadece kriptografik özelliklerinden faydalanmak için izin verilen bir yapıda blok zinciri oluşturmak biraz verimsiz olacaktır. Yani gösterildiği gibi burada Sağlık Bakanlığı merkezi bir otorite olarak yer aldığı senaryoda sağ tarafta merkezi bir mimari tüm ihtiyaçları aynı şekilde karşılayabiliyor. Diğer yandan aşı senaryosu için özel zincirlerin otoritenin dağıtımı prensibine uygunluğunu da değerlendirmemiz lazım. Burada doğrudan gösterilen yapıyı otoritenin dağıtımı prensibine dönüştürürsek şöyle bir temsil ortaya çıkıyor ekrandaki gibi. Burada aşıdan sorumlu hastaneler ve Sağlık Bakanlığı arasında kurulan bir konsorsiyum ağına ilişkin bir temsil var. Teknik olarak doğru olsa da bir kullanım senaryosu için hala verimsiz. Çünkü otoritenin dağıtımı prensibine uygulanabileceği senaryoda birbirine karşılıklı güven ihtiyacı duyan taraflar bulunmalı. Mevcut senaryoda ana otorite Sağlık Bakanlığı ve bu otorite hastanelerin güvenliğini hala sorgular durumdadır. Hastaneler ise paylaştıkları verilerin güvenliğini sorgulamamaktadır. Yani bu nedenle burada gösterilen otoritenin dağıtımı çözümü bir zincir uygulaması olarak değer katan bir çözüm olarak kabul edilmemeli aslında. Ancak ASI sertifikasyonu sadece bir ülke iç meselesi değil. Yani uluslararası seyahatlerde sorgulanan bir küresel mesele. Sağlık Bakanlığı ülke içinde yasal yetkiye sahipken buradaki merkezi çözümler ülke içerisinde daha uygun olabilir. Ancak uluslararası bir durumda yetki üstünlüğü olmadığı için her ülke diğer ülkelerin ASI sertifikasyon kayıtlarının güvenilirliğini sorgular. Bu noktada her ülkenin kendi sertifikasyon kayıtlarına ve diğer ülkelerin kayıtlarına güvenebileceği bir uluslararası konsorsiyum ağı oluşturur. Ve bu bir çözüm sunabilir aslında. Bu ölçekte düşünürsek, hani bu görsel genel bir blok zincirinde kurulan uluslararası konsorsiyumu gösteriyor. Bu ağda otorite ülkeler arasında dağıtılmış durumda ve ülkeler birbirleriyle güvenilir bir şekilde aşı kayıtlarını paylaşabilirler. Katılımcı taraflar arasında eşit bir güven ilişkisi olduğundan yani burada otoritenin dağıtımı çözümü bir blok zinciri uygulaması olarak değer katan bir çözüm olarak değerlendirilebilir. Bu bağlamda özel zincirlerden ziyade genel zincirlerden ilerlemek, blok zincir felsefesinin ve Web 3.0 yaklaşımının daha verimli şekilde izlenmesini de beraberinde getiriyor. Şimdi bu noktada gerçekten hangi kullanım senaryosuna ihtiyaç duyulur sorusunu sormak çok önemli. Buradan hareketle geniş kapsamlı bir analiz ve fizibilite doğrultusunda genel blok zincirlerinin en az 2 organizasyonun aynı ağda olduğu ancak düğümlerin tek bir tarafın mülkiyetinde olmadığı senaryoda ideal olduğunu gördük. Bu noktada hizmet operasyon yönetimi, Service Level Agreement deneyiminden yararlanarak aşı kullanım senaryosu gibi makro boyutlu projelerde detaylı olarak örnek kullanım senaryolarını inceledik. Hizmet seviyesi anlaşması, SLA dediğimiz, Service Level Agreement dediğimiz ölçüm kayıtlarının yönetimi, taraflar arasında güvensizlik ve çatışmaya neden olabilecek bir kullanım senaryosu oluşturduğunu gördük dünya genelinde. Ayrıca hizmet sağlayıcıların da birbirleriyle rekabet eden kurumlar olduğunu gözlemledik. Tabii bu sürecin şimdi tasarıda IoT cihazlarından elde edilen hizmet verilerini toplayarak tamamen otomatik hale getireceği düşüncesiyle yani otomasyona tabi tutulacağı düşüncesiyle bir proje fikri geliştirdik. Şimdi burada genel olarak üniversiteler, hastaneler ya da Havelsan gibi büyük kurumlar, şirketler, organizasyonlar yiyecek, güvenlik, temizlik, bakım gibi hizmetleri dış kaynaklardan ve hizmet sağlayıcılarından tüketiyor. Her hizmet sağlayıcısı üstlendiği hizmeti sürdürmek ve SLA'de tanımlanan şekilde karşılamak zorunda. Burada hizmet tüketici tesisi tasarısını görüyorsunuz aslında ekranda. Bu tesis örneğin hizmet sağlayıcı A ve hizmet sağlayıcı B tarafından sağlanan iki hizmeti tüketiyor. Bu tesislerin sağdaki uç cihazları, IoT cihazları bulunuyor. Ve bir IoT cihaz aydınlatma için işte kamera görüntüsü, sıcaklık, nem sensörü gibi hizmetlere ilişkin sürekli veriler elde edecek. Bu veriler IoT platformunda toplanacak. IoT platformu verileri işleyecek ve ilgili hizmet sağlayıcısının akıllı kontratına yönlendirecek. Akıllı kontrat, tesisin hizmet sağlayıcıdan beklediği hizmet kalitesi için SLA kurallarını tanımlayacak. Bu kurallar son cihaz yani uç cihaz, edge device aracılığıyla elde edilen verilerle karşılaştırılacak. Uyum sağlanmadığı tespit edilirse akıllı kontrat ilgili veriye bağlı olarak bir NFT oluşturacak ve bu NFT arıza bileti görevi görecek. Arıza bileti oluşturmak için de akıllı kontratı tanımlanan işlevi çağıracak. Şimdi mesela sistemde iki farklı hizmet kaynağından gelen işte hizmetlerin oluşturduğu akıllı kontratları karşılaştıracak. Sistem karşılaştırma sonucunda uyumsuzluk tespit edilirse akıllı sözleşmenin yani akıllı kontratın dağıtıldığı adres bu uyumsuzlukla ilgili bir NFT oluşturacak, bir arıza bileti oluşturacak dediğimiz üzere. Bunu da bir mobil uygulama üzerinden, internet üzerinden takip edecek. Yani Web 3.0 aslında burada devreye giriyor. İnternet uygulaması sayesinde bir sorun varsa yani arıza bileti varsa bu sorunu görecek, çözüme kavuşturacak ve NFT kaydının durumunu çözüldü olarak değiştirebilecektir. Böylece hizmet sağlayıcının sorun takibini ve çözüm oluşturması durumunu takip edilmesi sayesinde çözüm hızını arttıran şeffaf bir sistem kurulmuş olacak aslında. Şimdi bu tasarı SLA yönetiminde güven sorununu ortadan kaldıran ve SLA ölçümlerinin sürekli ve güvenilir bir şekilde gerçekleştirildiği bir Web 3.0 uygulaması olarak tasarlanarak amacına ulaşmayı hedefliyor. IoT cihazlarıyla entegre olan bu uygulama akıllı sözleşmelerle SLA tanımlarının sağlandığı ve takip edildiği güvenli bir yapı sunacak ve herhangi bir hizmet alışverişinde standart bir prosedür olan SLA yönetimini sağlayacak. Beni dinlediğiniz için çok teşekkür ederim.
Thanks for your presentation. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career, dear Hasan Tolga Ünal.
Thank you.
Dear participant, thank you for your attending. I wish all participants continued success. First session of the day is over. I would like to end this session. Have a good day. Good luck.
Have a nice day all. Bye bye.
Bye.